Still on the series on the lessons on motion under gravity, we are looking at this case when a ball, a body is thrown vertically upwards with an initial velocity u from the ground level. Now, this body, in the absence of air resistance, rises with a constant deceleration. Take note of that. It rises with a constant vertical deceleration. That means that the velocity of this body, the moment it is shot upwards, begins to reduce. The velocity reduces at a constant rate. The constant rate is called the deceleration of the body, provided air resistance is negligible. Now let's illustrate it this way. Suppose you have this body at this point, and this body is shot up. You agree with me that the initial velocity of this body, which must be given, let's use u to represent the initial velocity, is in the upward direction. And we all know that acceleration due to gravity or gravitational field is always directed downwards towards the Earth's surface. And because gravitational field has this downward direction because of attraction towards the center of the Earth, the acceleration due to gravity will also have this direction downward, which is 9.8 or roughly 10 meters per second squared. Now, if I decide to give this direction positive, because velocity is a vector as well as acceleration, in representing vectors, we need to define, we need to specify both its magnitude and direction. A vector quantity is not completely represented unless we state its magnitude and its direction. The magnitude is u, but mathematically we may use signs plus and minus to indicate the direction. So the direction upward, get it positive sign, so which means acceleration of the body, which is equal to the value of the acceleration due to gravity, the direction of that acceleration will give it as negative. So in this case, when the body is just projected from this ground level, the body starts rising. Remember, when it rises with decreasing velocity. The velocity keeps reducing because if the velocity does not reduce, why does it get to its highest point and start coming back down? Because when it rises to its highest point, at that point when it has reached its maximum height, its final velocity is equal to zero. At that instant, the body starts falling downwards because the velocity has gone from the value u may be 50 meters per second, for instance. If u, for instance, was given as 50 meters per second, which means at its maximum height, the velocity will have reduced from 50 meters per second to zero, and no more speed to continue in the upward direction. The body stays at rate momentarily at its maximum height and then start falling back down to the ground in this direction. Okay, but in this video, we are just considering the upward motion of this body, that it rises against the direction of gravity, the direction of acceleration due to gravity. And since its acceleration is negative, recall in my last videos I said negative acceleration is equal to deceleration. So we can rewrite the equations of motion or apply the equations of motion, equations of uniformly accelerated motion to this case. So that the first equation, which is v equals u plus at, we can rewrite it as applied to this equation, v equals u minus g times t. We are taking a, the acceleration of the body, as equal to minus g because of the direction. So we can take this as equation 1. Equation 2 simplifies to u equals s equals rather ut minus half gt squared. And equation 3 can be written as v squared equals u squared minus 2gs or 2gh. Let's put S. Now, since we are dealing with the vertical motion, we can take this vertical distance, that is the height risen by the body, as h. So sometimes we want to talk about the height of the body, maximum height and all that. We replace s with h. So that equation 2 can be written as h equals ut minus half gt squared. And equation 3 can be written as v squared equals u squared minus 2gh. This is when I'm looking for the height of the body after some given time. Okay, so that we can now find, let's say in this case, that the initial speed of projection was 50 meters per second. Now, what is the speed of this body after rising for 1 second? After 1 second of being in motion, what is the speed of this body? We use this first equation, v equals u minus gt. V equals u is 50, the initial speed, minus 10 times 1. I'm taking my g as 10, roughly 10 meters per second squared. So that the speed of this ball after 1 second of being in motion is 50 minus 10. That gives you 40 meters per second. 2 seconds later, what is the speed of this body? It is 50 minus 10 times 2, 2 seconds later. So the speed is this minus 30, this minus 20, that gives me 30 meters per second, and on, which means roughly 5 seconds later. Then time t equals 5. 5 times 10, that's 50. And then 50 minus 50 gives 0, which means that roughly 5 seconds later, the final velocity of the body is 0, meaning that the body is at its maximum point, its highest point above the ground. That's reached its height, because at that point, the final velocity of the body is 0. And then again, we can look for the distances covered for different time intervals. Let's say 1 second later, after when t equals 1 second, what's the position of this ball? How high has it risen above the ground? What's the height of this body above the ground? After 1 second, we can use h equals ut minus half gt squared. And then this is h equals, I use 50 times 1 minus half times 10 times 1 squared. So 1 second later, how high has this ball risen? H equals 50 minus 2 here, that gives me 5 times 1. That is H equals 50 minus 5, which is 45 meters. So 1 second later, this body, this stone, this object has risen a vertical distance of 45 meters. And then 2 seconds later, what's the position of this body relative to the ground level? Time t equals 2 seconds later, what's his height above the ground level? What's the distance risen after 2 seconds? The distance risen will be h equals 50 times 2 minus half times 10 times 2 squared, which gives me 100 minus 4. So this is 5, not 50, sorry. So 5 times 4 gives me 20. So that the height of this body above the ground is about 80 meters above the ground. That is 100 minus 20, and on and on. So you can see that the height of the body reduces for the first 1 second. That's raising a height of 45 meters. If it was rising at the same rate, it would have risen a height of 90 meters. That is, if it was the motion, maybe the case the body was rising at a constant rate, then after 2 seconds, it would have been 2 times 45, which is 90. But here it is 80, which means the height risen by the body decreases, with increasing time, because you see the speed is reducing. So that's why the height is reducing until when the body reaches its maximum height. So in the next video, we shall take more on this motion under gravity.